Hey, John here. I've recently done a couple of pushes up to the repo for the software as we get ready to release version 2.0 of the CPM BIOS. Most recently, I put stuff in here to allow us to configure SD cards with a little bit more flexibility than we used to. Let's take a closer look. As always, I'd like to put a big, deep thank you to all my patrons, especially the VIPs. You really help out. Thank you. So if you've been following along, you'd know that I've been putting some commits into the dev branch here. By default, if you go to the CPM repo from the main retro organization page, what you have is the main branch here. This is the last official release and marked as like version 1. And there's a pre-made version of it in here with binaries and stuff like that. You can just grab a big old zip file. So that's version 1, right? Now, as we get ready for version 2, what I wanted to do is overcome certain shortcomings. I mean, that's the whole point. You know, we're always actively working on this thing. So if, what am I doing here? I'm looking too low here. If you go over to the dev branch by doing this, you get to see that I've got 41 things that I've committed and other people have done pull requests and things that have been added to the repo since I last released main. Okay, so there's a lot of mods. Let's look and see at some of those mods. I've been talking about a lot of these for a while. I refactored the disk routines mostly so that we can have some more configuration, which allows us to have 16 drives now on here. Which was this one right here. And of course, when you do that, it needs a little bit more memory. So I had to change what we call the allocation block size. I explained all that a couple of weeks ago. And now I can make some corresponding changes to the main part of the BIOS. So these are all the things that have been going on for the last couple of months. This one right here is what I want to talk about today. Mode 1 flash boot support, and that means this. Now, I already talked about the changes that I made to the flash code in a previous recording. These are the corresponding changes that have to take place inside the CPM Retro BIOS. To use the information that I've now provide from the boot flash so that the BIOS can self-configure if and when it is booted from partitions that don't start at hex 800, which I've mentioned repeatedly over the year. All SD card formats, until you use this version, had to be configured in a very specific way, and the BIOS always booted off partition 1, and partition 1 must have started at block number hex decimal 800, or it will not work, period. This version, with these changes we're going to look at today, can boot off of any partition it wants, and it can be located anywhere on the SD card. And these are the changes that I made in order to make that happen. Turns out it's not that big of a deal, but it takes some planning. Okay, so let's look at the diffs first, and then we'll walk through the code in more detail. We can take a bigger picture type view to things. It's too bad this thing on the left is hogging up the whole screen. I just wanted to make sure. I normally do this on a terminal, but I wanted to make sure that everybody could understand and follow along, because you can easily do this also in GitHub, just like I did right now. These are the same diffs that I've shown and walked through in the past. If you look at them on GitHub, you see the green are lines that have been added. I put some blank lines in there, I guess, for formatting. The blue separates different chunks of things that have been changed. So near the top of the file, I added a couple of blank lines for whatever reason. Down here, and another part of this file, we'll talk more about which file it is in a minute, but just to get the lay of the land here, if you've never seen one of these diffs, I added a few more lines. Eventually, if I delete a line, it shows it in red like this down here, okay? So the greens are additions, the reds are deletes. That's seems similar to the command line diff that I normally show. So we go back to the top here. The way you read this thing is it says this is the name of the file that whose diffs are being presented down here. And you'll see there's more than one. As we go to a different file, there'll be another gray bar like this. And you can click this to close it down and move on to the next one if you want to, sort of thing. So in the call gate, what did we do? I added basically one line of code here. Along with a blank line, I did this. I failed to notice that when I initialize the BIOS, and I go through to initialize all the drives, it would be nice to tell the driver which drive is being initialized. And by doing this, I can propagate that information over when they're being initialized. It used to not matter, but and in fact, I don't think it matters now either, but in order to allow us more flexibility in the future, I would formally want to do this. I should have done it on day one, okay? Again, we'll look at the a more detailed view in a minute, but just to get this is kind of like the bullet list, bird's eye view before we dive into the details. What do we got down here? This is a space where, as my documentation says, I can save the 32-bit value, the high 16 bits and the low 16 bits, that represent the disk, the SD card physical block number, where the partition starts. This is going to replace the hard-coded logic that we saw in the past, where I just simply said, take the CPM track number and add hex 800 to it, because it used to be forced and mandated that the partition number 1 that we boot from had to start at hex 800. This is the main reason I made this mod that we're looking at today, okay? I want it to be configurable, so I have to now add whatever this 32-bit value is instead of just 800, all right? So that's our goal of the day here. Make that work. Along the same lines, because we no longer have hard-coded starting addresses for that partition, these configurations down here that I talked about before are not useful if they are all hard-coded starting at hex 800, as you can see. These are a bad idea. So I added a blurb of doc in here to specifically state that moving forward, when you use these macros to define, you know, a number of drives, or this was for 16 drives, which is ludicrous, by the way. I can't imagine ever needing more than 8 or even 4. But anyway, this version will support 8. The reason we want to cut down, even though it's nice to know we have all those extra drive letters. Well, they use a lot of memory. These macros consume a lot of space, ultimately, okay? So we don't want to have more than we need. So, all right, a couple of things. Number one, we don't want to hard code the absolute location on the SD where these things are located. So I replaced this with these down here. And you can see that for the first drive A, the offset is now relative to the beginning of the partition, which is wherever the boot flash says it loaded it from. And the boot flash ultimately will have that value stored in here, okay? During the handoff, and we'll see that code in a minute, the startup logic, the hard boot logic for the CPM BIOS is going to go and take the handed off value that says, hey, by the way, when I read in the operating system, I started reading from this exact block number for the partition that I loaded it off of. You're going to get that from the boot flash. And when the BIOS boots up, it will store that 32-bit value in these two variables right there, okay? So instead of having these hard-coded, they're relative to the beginning of the partition. And when we need to access the data, we need to take this value here, and we will add it to what was handed to us from the boot flash in here. That will represent the first SD block number of this logical drive in the boot partition, right? So the second logical drive starts at hexadecimal 4000, and then 8000 and C1000 and so on, because each one of these is 8 megs. And this number here times 512 bytes equals 8 megabytes. So that's why these are all 8 megabytes in size. They stack up next to each other. So one partition will have, in this case, 8 drives in it. Okay. I put an if 0 and I kept on, I finished it off for the 16. If you really want all of them, you can put that in there. But you got to be careful because we're using like all but, say, 10 bytes of the allocated region that I have set up for the BIOS in the CPM and all that. You may have to lower down the CPM base address if you want to actually have all 16 drives, especially if you turn on any kind of debugging, printing, or you're tinkering around with the code in there. There's some wasted space, and it may not fit, is my point. So unless you really need all of them, don't put them in there because you'll run out of memory eventually. Okay, so that's what's going on with those macros. I put another comment in here that says the driver that has the direct map cache doesn't use that offset yet. I didn't make any changes to that setup. So what happens is the configuration for the direct map cache still is a hard-coded absolute value in there. This is the commented out configuration for that direct map cache drive. Now what I did here is I just simply changed the doc. I wrote this is an absolute address, not partition relative. And I added that so you don't get confused if you're looking at the code, because all these are relative offsets based on the partition beginning, okay? This one is still absolute, okay? If you're going to use the direct map cache, you still have to start it at hex 800 for the first partition on the SD drive, which is no big deal. We've been doing that for over a year. Just leave it there. You don't have to move it if you don't want to. This down here is synchronized with the number of macros you instantiate up here. If I create 8 drives here, then only have 8 drives in down here as well. So what I did is I commented out drives 8 through 15, keeping drives 0 through 7. So we have 8 drives configured in there, okay? So that is the configuration, or rather I should say the call gate file. All right there, okay? This the macros are in the config ASM file. And what's next? The no cache driver. What's going to happen in the no cache driver is we're going to see a little bit different logic in here, because remember, we have to add the offset to the partition. We can't just assume it's at 800 anymore. So this is the code that adds two 32-bit values together in order to access a track that's properly located inside the partition that begins at an address that's stored in offset low and offset high, okay? And what else did we do in there? Well, it looks like a white space changed there. No big deal. What's going on here? A documentation change to let me know that I'm not dealing with a block number. I'm dealing with the offset into the partition in here. That this is the corresponding change of the macro itself that we saw used above when we changed it from absolute to offset. That's all. So in the actual Retro BIOS itself, the only change I believe is this right here. If we scroll down, yeah, this is everything. I deleted a blank line. But the only change to the actual BIOS is the startup code right here, okay? And all this does is it asks, am I booting from the new flash or an old flash? If you booted from the old flash, the accumulator will have a 0 in it when it starts entering the BIOS. So it just assumes that we started at 800 in hex like we always have, and it'll go the compare check for the accumulators right here, and it just goes on and boots it like it always has, all right? If, on the other hand, you've got a new flash or you're using some of the newer code that you see talked about in the Discord lately, people are writing into, like, configurable bootloaders and, hey, which partition do you want to boot from and stuff like that. They're going to want this. This is how their code has to work if they're going to use this BIOS. And when they start up the system going after they read it in off the SD card, they'll pass in the HL register and the DE register, the two pairs and I've talked about this before, last time when we talked about the flash, it'll pass in that starting SD card block number. We just simply save it and then apply it later using the addition that we glossed over above, okay? So that are all the changes as presented in diff format if you look at them on GitHub. All right, so now I'll just log on to my regular system here, my desktop. I'm on the dev branch, and I'm in sync with the repo code that we were just looking at. So I am going to go into Retro here. Let's look at some of these files. And I think I already mentioned I'm on the dev branch. This is not the main. This is the dev. This will be the next release. This is all the mods that we're working on here for this, right? So what do? We made mods to the call gate. We made mods to the config. We made mods to the no cache driver and to the retro ASM itself. The most critical ones, the diffs, I would argue, are fine. Let's look at the retro ASM. I would argue that's pretty easy to read from the diff as well because all the lines of changes are all right next to each other. But let's look at it in the bigger context. My goal is to make sure everybody follows along here. Remember that load base is set to hexadecimal C000 in the memory.asm file, which will configure where everything goes in the memory. Now, the way we size all this, remember, load base is set to C000 simply because when the flash loader runs that I wrote, remember, it simply blindly reads 16K bytes off the beginning of the partition that it's booting from. The flash loader still boots from partition 1, the version that I have in the repo today. But, as I'm saying right now, it no longer has to start at hexadecimal address 800. It can be anywhere. If it is anywhere, we execute this saving here so that we remember where it starts, because otherwise we have no way of knowing, all right? Now, load base is set to C000 because, and I talked about this like 18 months ago, because remember, the flash boot logic simply loads the 16K off the SD card and puts it into memory starting at load base, which we define in here as C000. It's up to this to do anything it wants, and it doesn't matter what it does or how it does it. The flash loader doesn't care. It simply is going to branch to this address after it reads all that stuff in, okay? So we wake up, this is a little review there. We wake up without knowing anything other than what's documented right here. If the accumulator is 0, then we know we must have booted off the SD card starting at block number 800, because that's how this system used to work for the last year and a half. Today, if you use a newer one or one of these configurable ones, we have to send in a 1 in the accumulator to let it know, hey, we've got these extra things we now need to use. Now, if A is 0, we just boot it the old way and move on. If it's new, we save the values, and then we go and boot it up. Now, why am I on about this C000 crap? So remember this. If you kind of jumped into the series late and didn't see the early ones, what happens here is what the doc says. Make sure that we fill the memory with enough bytes so that CPM base is where it is supposed to be. And I'm kind of air quoting. I need a camera for the shop here or something. But this simply pads the memory. And CPM base is also defined, I believe, in memory.asm. And the idea is that this will fill up a big hole in memory so that, while we read in 16K off the SD card, some of it's not used down here. This code down here can execute and do anything it wants, once and only once during the handoff from the flash. Then, once it goes to BIOS boot, it abandons all this code up here, and it becomes part of this standard TPA. It can be overwritten, and it will be overwritten, okay? Now, we want CPM base to be as high as it can possibly go. which means we want the operating system and the BIOS and everything to be as small as possible so we don't use as much, no more memory than we have to. So that's why all this padding is in here. We want to push it up really high. Now, let's say you want to have your 16 drives, you want to turn on all the debugging, and you got a bunch of extra code and it doesn't fit anymore. What do? You go into memory.asm and you change the volume of CPM base and move it down. Okay? Now, if you don't know anything about CPM, you probably shouldn't be playing around with this stuff, but I strongly recommend that you need to choose a value for CPM base. I would argue that's a multiple of I think it'll actually work if it's a multiple of hexadecimal 100, which is 256. But I would tend towards making it a multiple of 1,000 in hex, which is like 4K. All right, move it down 1,000, or at least you can't move it on a byte basis. All right, there's what we call alignment requirements. Okay, so don't get too creative about the value you put in here for CPM base. Make it end with 2 zeros, maybe 3. Okay, that's all I'm saying. Otherwise, it may not work. Okay. Once you get here, the BIOS is the same as it's always been in terms of how it boots and starts up and what it does. It ends up down here and does the usual thing and sets the latch and all this fun stuff and goes on its merry way and starts everything going. Okay, so that's the main change in retro.asm. Now let's take a quick look at the call gate because that's in there too. What do we change in here? We changed the one line of code that I added up here is right there. So what's happening here is during the initialization routine, a call is made to disk init. And disk init goes through a loop and it says for every one of the DPHs that are configured, which you have one of these for each one of the hard drives that you configure in the config file, right? It's going to go through this loop and initialize the driver, or more accurately, it's going to have to initialize all these disk parameter headers in any way they need be. Okay, it turns out right now there's not much, if anything at all, that really happens during this initialization. But in different kinds of I/O devices, we'll need more fancy initialization. So that's why this is all in here already. It's all stubbed in and ready to go. So what this is going to do is for each one of the configured drives, it will go out and it will put the address of the DPH that it wants to configure. It loads it into the HL register. Here, I've talked about this in the past. All I did here is store it in this DPH variable, which is the variable that represents the currently selected drive once we get in the driver, okay? So that the driver knows which one's being initialized. That's all. All right. Again, all right. Now, this is not critical. The current code we're looking at here that I'm going to release, but it will be in the future. So this was a nasty omission, a bug waiting to happen there. Okay. Now, it stores it in, where is it at? The variables that it puts it in are down here. I'm at the bottom of the file now. These are the new variables that I showed you before, all right, just so you have your wits about you here without having to worry about just that diff, all right, out of context. So this is in the call gate file, right? That's where these go. And you can see there's an 800 in there right now. The reason there's an 800 in there right now is because that is the default for backward compatibility. Remember, when the retro BIOS starts up, if A is 0, it does nothing at all and goes on its merry way like it always used to. But since I've modified the drivers now, the drivers need to know where the partition begins. It used to be hard-coded to 800, but now we need to allow it to change, okay? So the default is 800, but it can change. As I said before, the DM cache driver doesn't support anything other than starting at 800. The stub, which doesn't have any disk support, doesn't care, so it doesn't do anything new. And no cache driver does support this new configuration. Well, once everything's done and stable and everybody agrees and this is useful, then we'll worry about upgrading the caching driver and stuff like that as we go. So here's the bottom of the no cache file. Okay, that's where the DPB stuff is. And remember, before the DPB, we have these 3 pointers to the init, read, and write routines for all the disks that are configured as using the no cache driver. Okay, so they all have the same routines. This is in memory once. And then for each drive instance that you configure, of which we have 8, right, in the current default configuration, we'll have 8 of these macros expanded. And each one of these, I talked about this before, this is the ALV for each drive, and this is the thing that consumes up all the darn memory so that the BDOS can keep track of which blocks on the disks are in use and which ones are not. This has to be created once for each one of the drives, but the same init call, read call, and write call are used for all drives that are of the no cache configuration type. So let's look at the no cache init code. As I said before, there's really not much for this thing to do other than to invalidate its cache that it uses. Remember, there's a single block cache that it has to use in order to talk to the SD card, because the CPM wants to transfer 128-byte blocks, and the SD wants to use 512-byte blocks. We have a 512-byte buffer that we need to keep track of, which I talked about at great length when we designed the drive in the first place. So that's what's going on in the init code. The init code here doesn't care where the disk is on the partition and stuff like that, so it doesn't need to keep it in here. It does need to know during the read and write routines, which will directly just go out and use the variables in the call gate file that hold the high and low halves of the 32-bit value. Now that is actually done. Actually, it's right here. It's in the bottom of this routine. Now, I talked about this once before. Trevor Jacobs and I got talking about this in the Discord, and he came up with a nicer way to do this addition. So we don't have the hard-coded 800 anymore. So step 1 was, let's go ahead and do the addition correctly instead of hard-coded at 800 to add this adds the relative offset within the partition to the track number. All right. Remember that the CPM tracks in our BIOS have 4 sectors in them. So one track is the size of one SD card block. So what we do is we take the track number in the CPM. We need to add it to 2 things. All right. This code up here will add the track number to the starting block. I should put some doc in there maybe, but what it's doing now is it's adding the offset of where the file system begins, because remember, this could be drive A, B, C, and D. Okay, so what you have to do is you take the CPM track number and you do this addition up here, which adds the distance from the current partition, wherever that might be, to the beginning of the disk image for the drive letter that's being accessed. So if it's drive A, this code here will add 0 to the track number because that begins at the beginning of the partition. However, if it's on drive B, what this thing will add is 8 megabytes because that's how big each one of the disk images is. So it'll have to take the CPM track number and add 8 megs so that it uses the right disk image when it transfers the data, okay? And that's all fine and dandy, except you also then need to add the distance from the beginning of the SD card to the beginning of the partition, okay? So you've got the start of the partition plus the distance within the partition to the beginning of the CPM disk image, and then you have to add to that the track number, which is given an HL register. And we've talked about that in the past, okay? So there's simply 3 things to be added together now instead of 2, okay? And that is the whole ball game right there. Just keep adding all these relative offsets in order to figure out where your data actually is at, and all will be well. Now we can go up here and we can compile it. We compile everything. When I make world, it does it clean, and then it makes everything from scratch, and all will be well. Go into the file system directory here, and you can type make burn and all that, or you can test it by saying make n burn. Now I'm on my desktop here, which is called this. So this system needs to use SDC1 because my firmware still always boots from the first partition, but that first partition can now be anywhere I want to put it on the drive, and in the future we can play around with that boot and say, oh, I want to boot partition 1, partition 2, or whatever. Now if we go back to the doc for the CPM BIOS repo in here, remember there's a link in here that says here's how you set up a new SD card. And I got a little README file in here. And we spent a long time talking about SD cards and how they worked early on. There's a video earlier in this series. If you don't know, you probably want to know a few things about it, or you probably screw up all your stuff. Pay much attention, all right? Now, on my system, I have to be careful not to do this on SDA because I'm on SDC. SDC, and I've already partitioned this. As you can see, this is now partitioned to start at 135 megs through 269 megs. Until this version of the code, you had to start it at basically 1 meg, that's in kilos here, through 135. So what I did is I just moved this partition over somewhere else on my SD card, reburned everything, and booted it up to try it out, okay? So this is no longer starting at hex 800. Let me go ahead and quit out of here. Let's boot it up, and let's see if it works. And as you can see, when they power up, this no longer starts the way it used to. This now says, hey, I'm going to start at 40800. So I moved the starting partition from 0000800 to 00040800, okay? The number of blocks in the partition are the same as it always been because it's 128 meg, because that's how big 8 meg times 16 images is, right? Okay, and then the flash reads it in. It knows so now it's, hey, I'm reading from a different place. And it's going to do the usual thing. It's going to load the 32 in decimal or hex 20 of these 512-byte blocks into C000 through FFFF, which is where I've had it configured all along. We talked about this a moment ago when I talked about the memory ASM. This is the load base address in there, okay? So instead of booting from 800 through 1F or whatever, it's going to go from 40800 to 408, 1F, and copy that into here, which is what it means to move a partition to a different place in the on the SD card. So all works and all's fine. Let's see what's on drive B here. We should have 8 disks. This is the VDP test code. If I ever get done with this, we can finally get back to playing around with the VDP. Oh my gosh, people are writing games. I'm like, I feel like the whole world's going on having fun without me now while I'm doing all this housekeeping. But this housekeeping is kind of necessary. A lot of people that want to contribute are having trouble without, reasonable features in here to allow us to maintain different code bases and all the GitHub foolishness that we need to do in order to collaborate and all this other stuff. Great things are all happening because of this, but unfortunately, I feel like all the last 2 months have been a lot of grunt work, dirty work. I wouldn't blame you if no one's even made it through the video to this part yet. I don't even know. Post something in the comments below if you have. Anyway, the point is, this thing can now boot with your partitions anywhere you want on the drive. And as I suggest, then people are working on various projects where we might see fancy bootloaders and things that allow you to boot from partition 2 and boot from partition 3 or start up basic. or whatever. All right, all kinds of neat things now can happen because the Git repo is now partitioned. No pun intended. No coincidence. We're talking about partitioning today, right? Anyway, the repo is broken into pieces, so there's places for everything to go. So this is an exciting leap for me anyway. And it can now be more self-configured and flexible, and that's the whole motive behind all this changes today. So thanks for watching. Let me know what you think. If I could have done it better, let me know. Always room in the comments below. Thanks for watching. I'll see you next time.